Welcome to question number 14 of our series on trigonometry worked examples. Today the question is on aircraft design, or rather design of its wing. I have drawn an aircraft shape here. Let me give you a very quick fleeting description about the shape. Right in the front is a cockpit. Cockpit is where the pilots usually sit. I am using the word usually because you can also have pilotless drones. Right after the cockpit is a tubular structure called fuselage. That is where either the passengers sit or the cargo is stored or the weapons are carried. And for our purpose, we are assuming that the fuselage is uniform in shape. That is, it is neither tapering nor diverging. That means these two lines are parallel to each other. And in the rear is the tail. Now, there are two wings attached to the fuselage on either side. Obviously, both the wings are identical in shape and dimension. And the dimensions of the wing are given here. By the way, the wings are trapezoidal in shape and the sides of the trapezoid are given here. The wing in the forward direction makes an angle of 135 degrees with respect to the fuselage, and in the rear it makes an angle phi. And the width dimension of the fuselage is given as 5.4 units. Given all this information, we have to calculate these three. That is area of the wing, that is area of the trapezoidal shape of the wing, angle phi, and the wingspan C prime. What is a wingspan? Wingspan is the distance between the two extreme tips of the wings. That is, in this case, the distance between point C and C prime. Now that we have the full description of the aircraft, let it fly away. And for doing all the calculations, I'm going to use the calculator app in my iPad just to save time. So, without any further ado, let's start the calculations. First, let me list out the contents of my toolkit. I'm going to use three tools in today's calculations. One, the area of a triangle. That is, there is a formula for area of a triangle which is half AB sine theta, where A and B are length of any two sides and the theta is the angle between these two sides. And next is the law of cosine. Then the next one is the law of sines. Okay, now I have this trapezium A, B, C, D. I'm going to split the trapezium into two triangles. Calculate the area of each of the triangles and add them up to get the total area of the trapezium ABCD. For splitting the trapezium into two triangles, I'm going to draw a line CA. That is, I'm going to join point C and point A with a straight line. Okay, so I have split the trapezium into two triangles. That is, CDA is one triangle, then CBA is the other triangle. Now, in order to calculate the area of this triangle, I need the value of this angle and this angle. Let me mark this angle as theta. This is theta. Okay. Now, let us come to the angle CBA. That is this angle. It's very clear AB is a straight line. Therefore, this entire angle must be 180 degrees. This is 135. That is angle at point B. This angle is 135. Therefore, this angle must be 180 minus 135, right? So, angle CBA. 180 minus 135 is 45 degrees. So, the angle CBA is 45 degrees. 45 degrees. Now, we have to calculate angle theta. For that, I'm going to use cosine rule and I'm going to apply the cosine rule for the triangle CDA and ABC. First, let me apply the cosine rule for ABC and calculate the length CA. Apply cosine rule. First, the triangle ABC. Okay. Now, what does the cosine rule say? CA square equals AB square plus BC square minus 2AB BC cos 45, correct? Okay, now we have all the values. AB is 14.4. BC is 17.82 and cos 45 is 1 divided by square root of 2. Okay, now let me do the calculations using the calculator. So this should be equal to, so this gives me 162.01. Therefore, CA should be square root of 162.01. You may ask, what about plus or minus? We are going to take only the positive values. So square root of this, 12.73. Therefore, CA is 12.73. So this is 3. Okay, now we know CA. Now we have to calculate angle theta. For that, I'm going to use the cosine rule on triangle CDA. I can use this space. So, CA square equals DA square plus DC square minus 2DA DC cos theta. Okay, let's substitute the values. CA square is 162.01 equals DA is 11.38 square plus DC 5.69 square minus 2 11.38 multiplied by 5.69 cos theta. From this we can calculate cos theta and in turn the value of theta. So this should be equal to, let me use the calculator, 161.88. Let's do the calculation. So that is 129.50 cos theta. Solving for cos theta. It's a simple algebra. It is 161.88 minus 162.01, the whole thing divided by 129.5. Now, 161.88 minus 162.01. It's a negative number, right? So this cos theta will be negative, which means cos theta is more than 90 degrees. Or rather, either it is in quadrant 2 or quadrant 3. That is, it is between 90 and 270 degrees. Let's do this calculation. So this is negative 0.001. Therefore, theta will be cos inverse of minus 0.001, which equals 90.06. So theta equals 90.06. Let me put that number here. So theta is 90.06 degrees. Now we have all the information that is required to calculate the area of the triangle CDA and the triangle ABC, and we are going to add them up to get our total area ABCD. Okay, let's do it. I'm going to rub this and start in a fresh screen. Okay, so the area of the trapezium ABCD is the area of the triangle CDA plus the area of the triangle CBA. First, the area of the triangle ABC or CDA or whatever. The formula is 1 by 2 multiplied by length AD multiplied by length BC multiplied by sine 90.06 plus the area of the triangle ABC. It will be AB multiplied by BC multiplied by sine 45 divided by 2. I'm just going to substitute routinely and give you the final answer. DC is 5.69, sine 90.06 plus AB is 14.4 multiplied by 17.82. Sine 45 is 1 divided by square root of 2. Okay, I'm going to do this calculation and write the final answer. 123.10 square units. So the area of the trapezoid ABCD is 123.10 square units. So that completes our question number A. Let's go to question number B, that is calculate the angle phi. Okay, let's return to the question number B, that is calculate the angle phi. To start with, I would call the angle DAC as alpha. So this is alpha, and angle CAB as beta. Since the line AB is a straight line, angle phi plus alpha plus beta must be equal to 180 degrees. So if we can calculate alpha and beta somehow, then we can easily calculate the value of phi. And for calculation of alpha and beta, I'm going to employ the sine rule. First, let me apply the sine rule for the triangle DAC. Applying sine rule, sine alpha divided by DC must be equal to sine theta divided by CA, correct? Which gives sine alpha will be equal to DC divided by CA multiplied by sine theta. DC is 5.69. CA 12.73. Sine 90.06. Let me do this calculation using the calculator. So this is 0.45. Therefore, alpha would be sine inverse of 0.45, which will be, so alpha equals sine inverse of 0.45, which equals 26.55. So alpha is 26.55. Next, we are going to calculate beta. For that, I am going to apply the sine rule for the triangle ABC. Now, sine 45 divided by CA should be equal to sine beta divided by CB. Therefore, sine beta would be CB divided by CA multiplied by sine 45. Sine 45 is 1 by square root of 2. CB is given 17.82. CA is also given 12.73. Therefore, sine beta would be let's do this calculation. This would be 0.99. Therefore, beta is sine inverse of 0.99, which will be 81.82. degrees. Okay, so beta is 81.82. Therefore, phi plus alpha plus beta equals 180 degrees. Phi will be 180 minus alpha minus beta. Alpha is 26.55 minus beta is 81.82, which equals, that is 71.63. So therefore, the answer to our question number B, phi equals 71.63 degrees. Okay, done. Now we are done with question number B. Let's go to question number C. For question number C, let's bring back our aircraft here. Now, draw a perpendicular from point C to the line AB. Similarly, let me draw another perpendicular from point C prime to the line A prime, B prime. Let me call this point E and this point as E prime. And it is very easy to see from the diagram that wingspan CC prime is equal to CE plus width of the fuselage plus CE prime, or rather C prime E prime. Now that wings are identical in shape and size, CE must be equal to C prime E prime. Therefore, the wingspan would be 2 times CE plus the width of the fuselage, that is 5.4 units. So, let me draw a perpendicular from C to the line AB. Now, CAE is a right angle triangle because this is a right angle. Therefore, we can use the sine theta formula. That is sine 81.82 would be opposite side CE divided by hypotenuse CA. Right? We are going to use that to calculate the length CE. Therefore, CE would be CA sine beta. CA is 12.73 sine 81.82 degrees. This, let me do the calculation. So this is 12.60. So CA is, this is 12.60. Therefore, the wingspan would be 12.60 multiplied by 2 plus 5.4. That is twice CA plus 5.4. That is width of the fuselage. So 2 times 12.6 plus 5.40. So this would be 30.60 units. Therefore, the answer to the question C, that wingspan is 30.60 units. That completes the answer for all the 3 questions. I hope you found this question interesting. Please like, subscribe and opt for notifications. And as always, it has been a pleasure. Thanks for watching.